All right, question number 5. You have a word problem scenario. So this one is getting you prepared to be able to solve word problems when dealing with systems. So it says the sum of two numbers is 25. Their difference is -5. What are the two numbers? Let x be one number and y be the other number. And then they give you the equations already. So eventually it's going to come to the point where you're going to have to come up with these on your own. But we're giving them this time, and we just need to solve, put them in slope-intercept form. So one equation is x plus y equals 25. Just move the x over, and we have y equals -x plus 25. And then on the other equation, we have x minus y equals -5. So again, move the x over, it will become negative, but this y has a minus in front of it, so we're still dealing with the -y equal -x minus 5. And then we want to divide everything by -1, or you can say multiply by -1 to change everything positive. Mainly we have to change y positive, and so everything else is going to change with it. So we get y equals x plus 5. So here are the two equations that we need. So the first one, I'm just going to put a minus sign there, or a negative, and then 25. And on the second one, we need a positive, so just leave it as it is, and then a positive 5. So as I'm entering them, it graphs it down here. So I can see in the x direction, we get 10. In the y direction, looks like we get 15. Each line is counted by 5. So 10 and 15. So one solution, 10, 15. Okay, so number 6, we have a similar setup. We have a perimeter of a rectangle is 120. So 2x 2y equals 120. The length is 20 meters longer than the width. Find the dimensions. The length is 20 meters longer than the width. So they're letting x be the length, y be the width. Here are your two equations. We're going to solve for y, graph it, and then pick out the solution. Okay, so number 6, we have 2x plus 2y equals 120. And then x minus y equals 20. Move x over. 2y equals -2x plus 120 because it's positive. Divide everything by 2. Y equals -x plus 60. Move x over. -y equals -x plus 20. Divide by -1 to make this positive. Do the same to the other terms. And we get a positive y equals positive x minus 20. So here are our two equations. So -x and 60. And we get positive x and -20. Okay, so here they are graphed. In the x direction, we're getting 40. In the y direction, we're getting 20. So one solution, 40 and 20. And then do get in the habit of going back and just plugging in to double check. You can also graph it to double check, which I'll do it one more time. Turn this on, go to y equal. Now the reason I want to do it again is because I want you to notice some things will have to change in order for you to see or for the computer to give you the solution. So I'm going to graph these two equations, negative x plus 60, and then x minus 20. When I hit graph, over here these little lines are saying that it's graphing, now it's done. Okay, we don't see anything. Our graph has graphed these functions, but we're restricted to a 10 by 10 window right now. So we're only going up as high as positive 10 and down as low as negative 10 in both directions. So you can't see the graph, and if you tried to compute the intersection, second trace 5, and then you just hit enter 3 times, enter, enter, enter. It's thinking about it, and it says no sign change. When actually there is, but the calculator can't pick it up because it's not within view. Okay, so if we go back to graph, you can change the window. Okay, and you can always do this. I'm going to change this, and since our graph is on the positive side, it doesn't matter. I'm just going to go negative 50, and I'm going to go as big as a positive 100. And then I'm going to do the same thing in the y direction. I'm going to go negative 50. They don't have to match, but it's nice if they do. It might give you a more square window and a positive 100. And you can leave your window as big as you want. So now when you graph it, we're kind of zoomed out. Now we can see the lines. And now if you hit second trace 5 and then enter 3 times, you get that ordered pair 40 and 20. Okay, if you can see the intersection, the calculator will graph it. It will still graph it or give you the solution if you can't see it, but it has to be within the range of x. So let me show you what I mean here. So you can see the answer is 40, 20. I changed my window kind of like this graph so I could see it. So now I'm going to go back. So how do I go back? Go zoom, this middle button, and then 6 takes you back to the standard viewing window. Okay, well, we saw nothing. Now, since I know that my x answer is 40, you can fix this issue of not getting an answer just by changing the x direction. So if I make x, let's just say negative 100, and I make positive x, positive 100, I still may not be able to see where these lines cross. I don't see where they cross, but as long as the answer is on this axis, we will get the answer. So from here, I can still do the same thing, do second, trace, 5, and then enter 3 times, enter, enter, enter. As long as the intersection happens within the viewing window, within the range of the viewing window, it will put out your answer even if you can't see it. So you can make it to where you can see it, but if you make x big enough, your x-axis, it will pick it up no matter whether you see it or not. Okay, so 40 and 20 are our solutions here.